Now that we identified what data science is, let's come back to using data science to extract value out of data or to solve a question. How does the data science process function from the point of asking a question to answering that question? In other words, can we generalize the process steps that we started seeing in the soccer data analysis example and see how data science leads to insights? After this video, you'll be able to list some of the dimensions of modern data science and identify why analyzing these dimensions are important for us as data scientists. Our experience with building and observing successful data science projects can be summarized as a craft with a few distinct components. Those components can be defined as the key features or dimensions of data science. To summarize what we talked about before, we define data science as a multidisciplinary craft that combines an interdisciplinary team with an application purpose. So generally speaking, data science starts with a team of people with an overarching broad question and, of course, some data to explore. We can say that we start with data and question, and we build a process around how we come up with a data-driven insight. A process is a conceptual entity in the beginning and defines the core set of steps to solve the question. And then, from then on, drilling down to many areas of expertise, often with blurred lines between the steps. There are many ways to look at the process. One way of looking at it is as two distinct activities, mainly data engineering and data analysis, or computational big data science, as I'd like to call it, as more than simple analytics is being performed at this stage in general. A more detailed way of looking at the process reveals 5 distinct steps or activities of the data science process, namely acquire, prepare, analyze, report, and act. We can simply say data science happens at the boundary of all these steps. Ideally, this process should support experimental work and dynamic scalability on big data and cloud platforms. This 5-step process can be used in alternative ways in real-life big data applications if we add the dependencies of different tools to each other. The influence of big data pushes for alternative scalability approaches at each step of the process. Another way to look at this process is seeing all these steps with reporting needs in different forms, or drawing all these activities as an iterating process, including build, explore, and scale for big data as steps. Scalable data analysis needs alternative data management techniques, systems, analytical tools, and methods, as well as modes of scalability based on dynamic data and computing load, change in physical infrastructure, and streaming data-specific urgencies arising from special events. For simplicity, we will refer to the process as a set of 5 sequential activities that iterate in this course intro. However, at the end of the day, the scalable process should be programmable through utilization of reusable and reproducible programming interfaces to systems middleware, analytical tools, visualization environments, and end-user reporting environments. This final dimension, the programming of data science steps in Python, is what we will be focusing on in this course, with some examples in Python modules for analytics, data processing, and visualization.